So now the last part of this first section in 6.1 is looking at critical values. Now critical values are going to be important for now, but they're going to be even more important in the next chapter. So if you don't quite get what's going on in this section, we're going to see this more and more, and we'll see it again in chapter 7 for sure. All right, so critical values. For a normal distribution, a critical value is a z-score on the borderline separating the z-scores that are likely to occur from those that are unlikely. Common critical values are z equals 1.645, so we saw that, and z equals 1.96. So those are two special ones, but there's other ones. But now how you interpret this is a little bit funky, but we can still use our bell. Now the one thing you're going to notice is that they have a subscript for critical values. So there's always a subscript that kind of helps you identify where you're looking in your picture. Now it denotes an area of alpha to its right. So the subscript is describing area. So think area when you see alpha. So in this case, 0.01 is the area to the right. Now that's a pretty small area, so that kind of forces us to be looking on the right hand side. So they're saying that this is area equal to 0.01, and that's the z-score that you want you to find. So what z-score gives you an area of 0.01 to the right? That's the whole picture. So now how do we do it? We got to use our tables. But remember, our tables are restricted to looking on the left, so that's the first thing we got to do is just identify what the left side is. So 1 minus 0.01 is 0.99. And because it's area under the curve, we want to expand this to 4 decimal places. So 0.9900. So we do want to look at our positive z-scores. It's 0.9900. Now, 0.9898, 0.9901. Well, 0.9900 is in between these two, but it's definitely going to be a little bit closer to one of them. So let's kind of write all that down. So we got 0.9898 or 0.9901. And like I said, we're trying to get this, so we're going to want to use this one versus this one, because this one's a little bit closer. So we're not going to get it perfect, but it's going to be as close as we can get. So what z-score does that point to? So let's go back to our table. And so we said it was right here. So it looks like 2.3, and if we go up to the top, 2.33. So that should be our z-score. So that's what this is equal to. 2.33, that critical value. All right, let's do it a couple more times just to make sure we got it. So we got this z-score. Now again, it's hard to see, but it's 0.02. So if we draw our picture, so we have our critical value identified down here. We know the area on this side is 0.02. So over here, we know this is 1 minus that. So 0.9800. Well, so let's look it up on our table. 9800. Let's see. 9793. Oh, 9798. 9803. So again, we don't have it precisely, but it's between these two. So let's just analyze it again. 9798 or 9803. Whoops. So which one's closer? Yeah, this one's a little bit closer than this one. So now we got to see what this one tells us. 9798, which is right here. So we got 2.05. 2.05. So that is our answer. All right, one more time just to make sure. The nice thing is a lot of these pictures are just, you can draw them exactly the same. All it is just to kind of help you visualize it. So if we subtract first, so 9550 should be what we look up. Okay, 9550. Okay, so 9545, and then the next line is 9554. Okay. 9545 or 9554. Which one should we use? Again, we want whichever one's closest to what we actually want. Now in this case, it looks like this one's the closer one. So what does that give us for a z-score? Let's see here. 9554 is there. So 1.70. All right, so that is finding critical values. That's how we can do that. All right, so we're going to see how we can expand this whole idea around bell-shaped distributions that are not standard in the next section. So it's going to get a little bit more interesting as we go. All righty, see you in the next ones.